This video will go over prime factorization. So in order to understand this video, you will need to have an understanding of what a prime number is. Prime factorization is when you take a composite number and you break it down to its prime factors. For instance, if I take a composite number such as 8, what I'm asking is what prime numbers multiplied together will equal 8. So in order to figure this out, there are a couple of different methods. The one that I'm going to show you is called the factor tree. The factor tree is when you take your 8, and here it is by itself. You take this 8, and you can ask yourself what times what, besides 1 times 8 of course, what times what equals 8. So the one that I'm going to try is 2 times 4. If you said 4 times 2, that would work as well. And then we look at this and I say to myself, are any of those numbers prime? Well, yes. 2 is prime, so we can leave that guy alone. But 4 is not prime, so we need to ask ourselves now, what times what, besides 1, equals 4? Well, 2 times 2 equals 4. And then I stop again and ask myself, is 2 prime? Yes. So here we have all of our numbers are now prime. So what we have is 2 times 2 times 2 equals 8. These are our factors of 8. 2 times 2 times 2. Okay, so we have our 8, and we now know that the prime factors of 8 are 2 times 2 times 2. Let's look at another composite number. Let's look at 10. Now, 10 is a composite, not prime, so what two numbers can I multiply together to get 10? Well, how about 2 times 5? And again, if you said 5 times 2, that's okay. So I look at 5 and 2 and I ask myself, are they prime? Yes. So, the prime factorization of 10 is 2 times 5. Okay, so I moved my composites 8 and 10 both up to the left along with their prime factorization. So I'm going to take these two numbers and make them into a fraction so that we can see how to reduce fractions using this concept of prime factorization. So if I take my fraction 8/10, and 8 is my numerator, and I write my 8 in its prime factorization form, and then I take my denominator of 10 and I write it as its prime factorization form, then I can reduce this fraction using its prime factorization form. And so the way I can reduce this is that any number that is repeated in my numerator and is also repeated in my denominator, I can slice away. And so let me slice this away. A 2 and a 2, because I have them in both. Then I can condense my number, 2 times 2, and I just have a 5 left on the bottom, and now I have my completely simplified, reduced fraction. Even though I have more than one 2 on top, I can only eliminate as many 2's on the bottom as there are on top. And so I only had 1 2 on here, so I could only eliminate 1 2 on the top. So 8/10 reduces to 4/5. Okay, let's take a much bigger fraction, 24/72. So I'm looking at this and I'm thinking, gosh, how do I reduce this, and how do I make sure that I've reduced it all the way? And so the easiest way for me to make sure that I've reduced it all the way is to use my prime factorization technique. So I'm going to start with my 24, and I'm going to ask myself, what times what will equal 24? Well, here is one where I could use 8 and 3, or I could use 4 and 6. It doesn't really matter which one I use. I will end up with all my prime factors no matter which numbers I start with. So I'm going to use 3 and 8. Well, 3 is a prime, so I'm going to circle that guy because I'm done with that. Then I do my 8. I can do 4 and 2. 2 is prime. 2 and 2. Okay. So my prime factors of 24 are, we've got 1 2 3 2s, 1 2 3, and 1 3. I like to slash through my numbers so that I make sure that I don't forget them when I rewrite them. I also like to circle my prime numbers so that I don't accidentally use numbers that are not prime, like 8 and 4. You should only use the numbers that you circled, and those numbers should be prime. Okay, let's look at 72. Well, what times what equals 72? Well, 9 times 8 equals 72. And if you didn't know that, you could at least, divide it by 2 and then say 2 times whatever equals 72. I know 9 times 8 works. 9 is not prime. So I need to split that up into 3 times 3. Those guys are prime. And then, as we already know, 8 is 2 times 2 times 2. So 2 times 2 times 2. Okay, so I don't want to forget any of my numbers here, so I know I got to do 3 2s. 1, 2, 3. And now this time I have 2 3s. 1, 2. Okay. So here is this guy broken down into its prime factorizations. Okay, I've cleaned my screen up here a little bit, and I've just rewritten it now just to show you the prime factorizations pulled out. I have 24. Prime factorization of it is 2 times 2 times 3. And then I also have my 72 here, which is 2 times 2 times 2 times 3 times 3. Now, as I did on my first problem, I now want to go through and cross out any prime numbers that are repeated on the top and the bottom. So, 2 and a 2. And here I can do another one, 2 and a 2. And here I can do another one, 2 and 2. And here I have 3 and 3. Well, what's left? Uh-oh. I have nothing left up here, or do I? Remember our property that says any number times 1 is that number. So anytime you cross out all numbers, remember that you actually still have times 1 on the top. So it does not become 0. It becomes, the 1 is left over. So what do we have left over here? I can write that better. 24 over 72 equals 1/3. And that, my friends, is the completely reduced fraction of 24/72. So now that you can understand how to reduce fractions, here's how to reduce two fractions that you're multiplying together before you finish solving the problem. For instance, imagine I have this fraction, 2 2/3 times 5/24. Well, step one, of course, when multiplying two fractions is when we have a mixed number like this, we need to create it into the improper fraction. And I'm not going to go over that step. If you need to know how to do that, you can watch another video. Well, I'm going to do it right now, so maybe you'll get the idea. What you do is you multiply 3 times 2 and then add it by 2. So 8/3 times, and let's use this dot instead of the multiplication symbol from above, but this dot means multiplication. Here I have 8/3 times 5/24. Well, 3 and 5 are prime numbers, but we know that 8 and we know that 24 are composites. So before I solve this problem, I'm going to change my 8 and my 24 into composites. Okay, as we have seen previously in this video, 8 is factored out to 2 times 2 times 2. So we can go ahead and write that one out. 2 times 2 times 2. And we should factor out 24, which we have also done previously. But I'll just do it again really quick. And we have 1, 2, 3, or 8 times 3. Okay. Now the neat thing about fractions is that I can just slide this into one big fraction and have the multiplication sign on top and bottom. And now anything that's repeated on top and bottom I can eliminate. So I have a 2 and a 2, a 2 and a 2, a 2 and a 2, and that's it. So what I have left on the top is a 5, and on the bottom I have a 3 times 3. So my answer is 5, and then 3 times 3 is 9. So the answer to this guy in its reduced form is 5/9.